Now we're going to add some more to this. One of the things with acids and bases is not that there are lots of different calculations you need to do, but the questions very quickly turn into multi-step calculations. And we've seen that already, where you can get multi-step calculations in here. I'm going to just simplify this a little bit by rubbing out that, and rub out that, and rub out that. Right, so let's assume we know how to go from a strong acid to a concentration of hydrogen ions or a strong base to this. We know for a weak acid and a weak base what to do. Let's rub out that just to simplify the diagram. Now, the next sort of question they might give you is mixing an acid and a base. So if I mix an acid and a base, or there's some sort of reaction involving acids and bases, then I need to work out the pH at the end. A standard example might be neutralisation, where I add an acid and a base, but I don't know if I've added exactly the right amount for a neutralisation. If there's exactly the right number of moles of acids and bases, acid and base for neutralisation, then I'll get just the salt. I've got no acid left over, no base left over, just the salt. And that would become a question where, what exactly is the pH of that salt? It's going to be close to 7, but is it an acidic salt or a basic salt? But often, one of these will be in excess. Either I've got too much acid or I've got too much base. So if I'm given a question where I've added an acid and a base, and I need to work out the pH of the resulting solution, what I need to do is work out which of these is in excess and what is the concentration of it. That's all these questions are. So let's say, for example, to keep it a nice simple example, I have 1 mole per litre. Let's say 1 litre of 1 mole per litre sodium hydroxide and 1 litre of 2 mole per litre hydrochloric acid. Now, I've deliberately given easy numbers so you can see straight away that that's in excess, but the numbers won't always be that simple. What would we do if we're given a question like that? We've got to work out which is in excess. And the way you do it is you work out the number of moles. So what is my moles of sodium hydroxide? Well, you're going to use the formula. You know concentration is moles per volume. So the number of moles is CV. And I can use this N equals CV to work out how many moles of acid, how many moles of base. Well, how many moles have I got? The concentration of this sodium hydroxide is 1 mole per litre, the volume is 1 litre. So I know that my moles of NaOH is 1 times 1 is 1 mole. Right? I've deliberately kept it simple. The moles of HCl is CV, concentration is 2 moles per litre, times 1 litre is 2 moles. So I have 1 mole of sodium hydroxide, 2 moles of hydrochloric acid. Now I would need a balanced equation, because to work out which one's in excess, I need to know how many moles of this react with each mole of this. In this case, it is 1 to 1. And so I could work out from this that if I have 2 moles of the acid, 1 mole of the base, and they react in a 1 to 1 stoichiometric ratio, I'm going to have 1 mole of HCl in excess. Okay, and that's what I'm interested in these sorts of questions. What do I have in excess? If I've got 1 mole of HCl in excess in this solution, and the solution, because I mix 1 litre of this and 1 litre of this, I've now got 2 litres, I can work out the concentration of hydrochloric acid. 1 mole in 2 litres, I must have 0.5 moles per litre. So what have I got now? I've got the concentration of the strong acid. That's where we've ended up. And I can go through all of this. Now, what's the point of that? What am I trying to show you? If I add an acid and a base, and I'm asked to work out the pH of the resulting solution, all I need to do is work out which one I have in excess and what its concentration is. Just ignore all of this for a minute, ignore the pH, work out which of these in excess is in excess, what is the concentration. You can do that. You work out how many moles of each one, use the balanced equation, you can work out what you've got in excess and what the concentration is. As soon as you know the concentration, so you add these, you find which is in excess. Are you going to do that by calculating the moles of each? By finding moles of acid and the base, and you're going to use the ratios in the equation. So doing that, I can work out which I've got in excess by finding the moles of each, using the ratios in the equation, and then I can calculate the concentration of the acid or the base that's in excess. As soon as I've got that concentration of acid or base, it feeds straight into this. I can use whichever is appropriate. I can work out any of those. So neutralisation, that would be a good sort of question. Give you a weak acid and a strong base, tell you the concentration of each and how much was mixed, ask you the pH of the resulting solution. It seems really confusing and complex when you first hear it, but if you break it down into steps, all you've got to do, ignore the fact that they're weak and strong initially when you're doing the moles of each. So you work out how many moles of each, use your ratio in your balanced equation, work out what you've got left, what's its concentration, and then you can go into whichever is appropriate. And that's when, if it is the weak acid or base that's in excess, you'll have to use an equilibrium, Ka or Kb.